Hello everyone. In this video we're going to look at how to solve tutorial 9 solution for problem 1 phase diagrams. So quickly looking at the question, it says at a 90 weight% silver and 10 weight% copper alloy, if it is heated to a temperature within the beta plus liquid phase, if the composition of the liquid phase is 85%, what is the temperature of the alloy, composition of beta phase, and mass fraction? So the overall composition, I've already drawn a line here and I've labeled it as composition O, so that's overall. So I've got this alloy composition and I'm heating it till it gets to the beta plus liquid phase. Now once it gets to this region, we already know that at the composition of liquid phase 85 weight%, what happens? So at 85% liquid phase, I'm going to go ahead and draw a line. So at composition of liquid 85, it intersects the liquidus line at a point. Now if I extend this line all the way here, I could find out the temperature of the alloy at liquid phase 85%. So the answer for question number 1, the temperature of the alloy would be 850 degrees C. Okay. Composition of beta phase. So to find out the composition of beta phase, I need to draw a tie line here. So I'll go ahead and draw a different color tie line. Maybe a nice bright pink. So I'll draw a magenta tie line. So that is my tie line. So the point at which it intersects the solvus line, if I extend that down, that is the composition of the beta phase. So I'm going to draw another extension here. So we've got the composition of the liquid phase, composition of the beta phase, and overall composition. That is our tie line. So we've answered question subdivision A, temperature of the alloy 850 degrees, composition of beta phase. So if I extend this down, it's 95. So that is the composition of the beta phase. I'm going to go ahead and label it. Okay. Now, if we want to find out the mass fraction of both phases, both beta and liquid, you have to use the lever rule. What does the lever rule say? So I'm going to label this length, that is from the composition of the liquid to the composition of overall composition. I'm going to call it as R. I'm going to call this distance as S, and the distance from composition of liquid to composition of beta, I'll call it as T. Okay. So if I was going to find out the mass fraction of beta, the formula is R divided by T. If I was going to find out the mass fraction of liquid, it is S by T. Now the formula is already given here. So the mass fraction of beta is R by T. So what is R? Sorry, yes, no, that is correct.